Hi everyone, thanks for checking out this video about basic statistics and probability in real life. Some of you may have followed the last two election cycles, and you may have noticed that the polls were very inaccurate, if not totally wrong. Many of you may agree that this is a very sensitive topic, and that it is sensitive to even talk about the accuracy of the polls should have already given you some idea why the polls could be so inaccurate. In this video, my intention is to analyze this in a more academic fashion with some basics of probability theory. If nothing else, I hope this can sort of guide you to think about the polls from a more objective and a scientific perspective. So, just how wrong were the polls? Let's take a look at the Florida in 2020 election. The polling average has Biden leading by 0.9%. In fact, most of the polls have Biden in the lead. The final vote has Trump leading by 3.3%, a pretty big 4.2% difference. If you remove the poll by this Trafalgar group from the average, which was basically ridiculed and dismissed by almost all other pollsters or the media, but in fact is the most accurate in this particular state. If you exclude it, you'd get an even larger difference. The polls were even more inaccurate in Ohio. The polling average, which includes the last two polls, has Trump leading by 1%. But again, most of the polls actually have Biden in the lead until the very last two polls. The final vote has Trump leading by 8.2%, a whopping 7.2% difference. If you exclude the last two polls by Rasmussen and Trafalgar, which were basically laughed at by almost everyone else, the difference would obviously be even larger. So why were the polls so wrong? You may have heard of many reasons, like the sample size was too small, or many people didn't even want to talk to the pollsters, or some people may just straight lie. You may have heard of so-called shy Trump supporters, who may tell the pollster they would vote for Biden for whatever reason. Maybe they don't trust the pollsters or mainstream media, or they don't want their friends or family to know that they have a different opinion that's considered not acceptable by common social values, the so-called social desirability bias. There could be shy Biden supporters as well. Imagine a Biden supporter in a primarily red neighborhood. She or he may feel threatened to show their support for a Democrat candidate. The truth is, it could be all of those reasons that cause the polling data to have issues or flaws. However, they should not be the reasons the pollsters gave us these inaccurate interpretations of their data. Yes, the polling data has issues, but the pollsters should have done a more diligent job to interpret their flawed polling data in a more scientific way. This is obviously a very difficult and complex problem, and I don't intend or claim to be able to provide absolute solutions here. But rather, I'll try to use a simplified example to introduce some basic probability concepts and a somewhat more correct, or at least a more scientific way to interpret the data. Hopefully, this can be helpful so that you can form your own ideas when you look at those polling data instead of just taking the pollsters' interpretations for granted next time around. Okay, so let's look at a simplified example. Say you poll 100 people. 55 of them say they will vote for Biden, while 45 for Trump. The question is, what percentage is actually voting for Biden or Trump? Naively, this seems easy. 55% for Biden and 45% for Trump. But as we mentioned earlier, the interpretation of the polling data is in fact not so simple. To illustrate, let's try to connect the actual with the poll. For an actual Biden supporter, very likely they will answer Biden. However, there's also a probability that they say, hey, I'm voting for Trump, even though they actually would have voted for Biden. Similarly, for For an actual Trump supporter, they likely will say they're going to vote for Trump. However, suppose they happen to be a shy Trump supporter for whatever reason. They may just say, I'm voting for Biden. Now let's make some assumptions. Imagine among the 100 people who are sent questionnaires, 50 are actual Biden supporters and 50 Trump supporters. So 50-50 actual even split. And further, we assume the actual Biden supporters will say, I'm voting for Biden with 100% probability. So no Biden supporter will say, I'm voting for Trump. No, this is not necessarily true. It's just an assumption we are making here. On the other hand, for an actual Trump supporter, only 90% of the chance they say they will vote for Trump. There's a 10% chance that they say they are voting for Biden. Based on these assumptions, we can see for 50-50 split of actual Biden-Trump supporters, 50 Biden supporters answer Biden, since we assumed 100% probability in this case. No one answers the poll saying they are going to vote for Trump. But among the 50 Trump supporters, only 45 answer Trump. The other 10%, 5 out of the 50, say they will vote for Biden. So these assumptions will give us 55 Biden, 45 Trump, as in the polling data, even though in reality, it's a 50-50 actual even split. Remember, we made some specific assumptions above. Now let's try another set of assumptions. Instead of 50-50 actual even split, let's assume 49 are actual Biden supporters, while 51 actually support Trump. Again, if one is a Biden supporter, they will answer the poll with Biden, with zero probability that they say they are voting for Trump. Now, for the 51 Trump supporters, let's assume, again, 45 of them say they are voting for Trump, and 6 of them say they are going to vote for Biden instead. In the so-called conditional probability terms, this means given someone being a Trump supporter, the probability of them saying they are voting for Biden is 6 out of 51, or about 11.8%, compared to 10% in the previous set of assumptions we made. This new set of assumptions lead to the same results of the polls, 55 for Biden and 45 for Trump. Let's summarize what we just said. We made 2 sets of assumptions, and both of them lead to the same results that are consistent with the polling data. 50-50 even split with 10% shy Trump supporters, or 49-51 split with 11.8% shy Trump supporters. You can consider these 2 sets of assumptions as 2 different models, and you can imagine there can be many models that can lead to the same polling results. For example, in the case of 48-52 split of actual Biden-Trump supporters, if 7 out of 52 Trump supporters, or 13.5%, are shy Trump supporters, you get the same results. Similarly, in the case of 51-49 split, but 4 out of 49 are shy Trump supporters, you get the same results again. Now, this is the key in the understanding or interpretation of the polling results. You have the results, which is the data of the experiment, polls in this case, but you simply don't know which model is the correct one. What you need to do is that, given the data, infer which model is the correct one. In fact, you cannot even do that. A more correct way, or at least a more scientific way, is to use the so-called Bayesian inference. In the Bayesian framework, you can only infer the conditional probability of a model, given the data you collected. And that conditional probability is further dependent on some further assumptions that we haven't even included here, the so-called priors in the language of Bayesian probability. It's okay to be a little confused here because it's a complex problem. However, the posters, when they try to interpret the polling data they collect, should not be as confused as you or me here. They should try to figure out the most appropriate priors to use and the most appropriate configuration or assumptions of the model to apply. In our case, the model includes the actual percentage of Biden supporters and its complement, the actual percentage of Trump supporters, and the probability of a Trump supporter saying they will vote for Biden. We actually simplified the model by assuming zero probability of a Biden supporter saying they will vote for Trump. That is, no shy Biden supporters, while there's non-negligible shy Trump supporters, which may not be true at all, and it will obviously make the model even more complicated if we include both shy Biden supporters and shy Trump supporters. For those who are interested in further research of this subject, I want to provide more food for thought here. As we were saying in the Bayesian framework, you cannot really say which model is correct. You can only infer the conditional probability of a model given the data you collect. So the question we were asking, what percentage are actually supporting Biden or Trump? Is that even the right question to ask? If not, what should be the right question to ask? Another question which I believe will help one further formulate the analysis of this subject is the following. If you randomly poll someone and they say they are voting for Biden, what's the probability that they're actually voting for Biden? This is not the same as the probability of the other way around. That is, what's the probability of an actual Biden supporter answers the poll with Biden? So these two probabilities are actually not the same. Assuming the answer is X. Now, if we randomly poll 100 people, as in our simplified example, what's the probability you get a 55-45 Biden-Trump split as in the polling results? Some of you may have guessed you need to do something like x to the power of 55 and 1 minus x to the power of 45 with some coefficient. This is based on so-called binomial probability distribution. Finally, in order to analyze the probability more correctly, one also needs to understand the probability distribution of continuous variables, since the x can be any real number, not just a few numbers available. Finally, we have mentioned the Bayesian framework here. It's a different way to interpret the data from the traditional frequentist framework. So for those of you who are interested in this, you can do some Googling and try to find what the difference is between these two ways, pros and cons, and which way is the better choice in different contexts. That should help you understand probability a lot better as well. Okay, I'll stop here. The end of this video may be quite confusing, but I would say it's supposed to be confusing to people who are not doing probability on a daily basis, because it is a complex problem. Otherwise, the polls, or rather the interpretations of the polls by those posters, would have not been so inaccurate. However, I hope the simplified example and its illustration has provoked your own thoughts and at least will help you form your own ideas about polls in the future. Instead of taking for granted the interpretations by the posters, who, as you may have learned from the complexity of the problem, may have simply just missed the point. Thanks for watching this video about statistics and probability in real life. Hopefully, see you next time.